Okay, so we have a file to download for today. Here it is, isbn10.xlsx. Well, I've downloaded that. We're going to go ahead and open it up. While you're getting that open, in fact, before we look at this sheet, maybe I'll just make a blank sheet here. We're going to play a little game, a little thought game. How old were you in the 1970s? I'm just kidding. I know you weren't born in the 1970s. I was barely born in the 1970s. But I'm going to have you, what am I doing here? First, I'm going to make the screen black. And then I'm going to change the font color to kind of a light green and bold. Okay, so now I'm going to cast you in a role. You're a manager of a bank. And what's the big innovation in banking? It really starts in the 1960s and comes full swing in the 1970s. What's the big innovation in banking? I don't know why you would know this, but it's the use of computers to manage your records. So we kind of start to get the first business use of computers in the late 50s, and then it kind of gets into banking in the 60s. And by the 70s, if you're not moving into computing, you're behind the times. It seems strange for us to think about it now, but it used to be that banks were closed one day every quarter. I mean, they would still be closed on the weekend, but on a weekday, they'd be closed every quarter. Why? To apply interest. You know, all right, we got to close up the bank so that we can apply interest to all these accounts. We go through and calculate by hand the interest that accrued over the last quarter on these balances, write it in, and move on to the next one. We'd close the bank to be able to do this. And so the thought of having computers that could do these calculations really well seems like, oh, this seems like really great. So what we're going to do is we are going to design a screen for this new so-called computer system. This screen is just going to be to make a cash deposit. So what information do we need to be able to make a cash? Someone's going to walk up to the teller with cash in hand and say, I want to deposit this money into my account. What information do we need to record? The account number. ACCT number. And then maybe I'll make this kind of that same light green. And we'll make the letters here black. Okay, what else? Is that it? What else? Amount. Excellent. You guys are good at this game. So now if someone comes up, you know, and we say, ultimately, we might have to do something to help look up an account number, but we're going to keep that separate. So someone comes up with a deposit slip that has an account number written in it. They fill out the deposit slip, you know, probably put their name, their account number, and they've, you know, put the amount on. Now we're ready to process that transaction. What's the risk here? Someone's going to deposit 50 bucks. What is the risk? Risk is this is a manual process. You're going to type in the wrong account number. What's the big problem if they type the wrong account number? That money is getting deposited. We're taking the money and we're putting it, you know, back in the vault. But if we get the wrong account number, it's going to be accredited to the wrong account. I mean, this is the big thing that banks do. They got a big pile of money sitting there, which they're going to loan out. They're going to keep track of, you know, who do we owe this money to? And when we lend this money out, we're going to who owes this money to? We're keeping track of all this information. So we get the account number wrong, that's a problem. So we got to figure out how we're going to make sure we don't make the account number wrong. Now, in the 1970s, things that we take for granted today are really expensive. One is reading or writing to a disk. That's expensive. Two is accessing something across a network. So do we have networks in the 1970s? Absolutely. So, you know, we could have one branch at a bank that's communicating with a central office. You know, it happens over something that's crazy slow by today's standards. So it's really, really expensive to look something up in the bank's database. So we got to figure out, what are we going to do to validate this? 1970s, how are we going to validate it? How are we going to make sure we don't type in the wrong account number? You know, what's your thoughts? What are you going to do? Any thoughts? Okay, so one could be we have someone else check it. And maybe one way to do that is have someone else like type it in, right? So you're going to type in the account number. I might type it wrong. Someone else is going to type the account number, but the chances of getting two mistakes exactly the same, really, really slim. So that's pretty good, but it's also really expensive because now it takes twice the labor to be able to do the transaction. So there's some great things about it, but it's pretty expensive to have another person. So you might say, well, we'll just have the same person enter it twice. And that works pretty well if the error happens between the brain and the fingers. But if the error happens on the way into the brain, I'll be thinking of the wrong number and I'll type the wrong number correctly twice. So double entry is not going to do it really well for us. Go ahead. So we have type in the name, and then we could check that name to make sure it goes with the account. That would be great, except it requires a trip to the database to answer that question. And that's expensive. And so, how long might it take? It might take 15 seconds for that to happen. And that's a long time for every transaction to add that 15 seconds onto it. Not to mention the fact that if we've got all these transactions now, that each one's hitting the database like this, I'm not sure our database can handle it. So 1970 is a different time. So that's tempting, but probably not going to work for us. That was something similar. Go ahead.
Could you do you still use their first name, but you figure based off of their first name? And so you put in the right first name, then your account number is good.
Okay, so what you're saying is, somehow give us your name, and we could use that name somehow to do some kind of math on it. Math's pretty inexpensive for us to do. Do some kind of math on that would allow us to actually calculate part of what that account number should be. So we could verify it against the account number itself. Yes. Now we're not going to use the customer's name for it. That's exactly what we came up with in the 1970s. There's something called a checksum. So I take 1, 2, 3, 4, 5, 6. I add those numbers together. The sum is 21, and I will put that 21, and that will become a part of the account number. So whenever we print the account number, there's a portion of the number that identifies the account, and then a portion of the number that just allows us to make sure that we've entered the number wrong. So now, any single character gets typed wrong here. Any single one of those is wrong. We can tell immediately because they'll no longer, if we've made a mistake here, well, then the first 6 will add up to 21, but this won't say 21. If we've made a mistake here, maybe 3 is a 8 instead of a 3, then it won't add up to 21. And so we can, without reading to a disk, without going across a network, we can immediately go, that's not a valid account number. Go ahead. The most common typographical error is 2 sequential numbers transposed. And so this doesn't solve that problem. Good point. Now, it turns out this is kind of our first step into this area, and that was exactly the problem that came up. We're still getting these errors. What are these errors? Oh, these are all transposition of sequential digits. And so then we got some pretty smart people to think about, well, how could we improve this algorithm? The algorithm's simple. Add up the first 6 digits. How could we make an algorithm that's somewhat more sophisticated that would protect against 2 sequential numbers being transposed? I'm not asking you to answer that question. That's what we tried to think about in the 1970s. And you might think, yeah, but how smart were they in the 1970s? I mean, I looked at their fashion choices, and those were pretty weak. So, but a lot of smart, like mathematicians, their fashion choices are always pretty weak, so I don't think we can really look at that to decide that. So, yeah, so this was kind of the first step into this area, and then we came up with something else. We said, look, not 21 at the end here, but just 2. If we could come up with an algorithm that's more complicated than just adding up the numbers, but would only produce a single digit as the outcome, and would protect against any other number just being typed wrong and any 2 sequential numbers being transposed, then we like that. That's pretty good. And so that is what is referred to as a check digit. And check digits are in every identifier that people have to type in on a regular basis. So any kind of number you have to type in, like a UPC code, like on the back of your boxes of ramen or whatever, there's a check digit built into that. I don't know where it is. It's almost always the last character, but there's no reason it has to be the last character. It can be put anywhere. And so that number gets typed in, and we can immediately run the algorithm on the whole number and check to see if the check digit is what is calculated by that algorithm. And then we can validate it very quickly if it's a well-formed number. And so now it would take 2 errors that counterbalance each other for me to be able to get a well-formed number that's the wrong number, and that's extremely rare. So we feel pretty good about that. So what we're going to do in class today is we are going to work with calculating an algorithm for a check digit, and we'll get to that in just a second. I just got to tell a quick story about this because it's kind of fun, about one of my former colleagues here at BYU. Who knows the name Frank Abagnale Jr.? Yes, who is he? Well, the author of Catch Me If You Can, which was his memoir. So yeah, he was a financial fraudster. I mean, now he's a highly paid, I don't know if he works for the FBI or if he consults with the FBI, but he's now catching people who are out perpetrating financial fraud. But this was actually his first financial instrument fraud was this. His very first fraud was credit card fraud. It was really pretty unsophisticated. He was really young at the time, 16 or 17 years old. But his first financial instrument fraud was this. I mean, what does, Edna gets her Social Security check and she goes to deposit at the bank. How does she do it? So, like kind of back in the day, if she's got her checkbook with her, she'll take a deposit slip out of the checkbook. This deposit slip is pre-printed with her account number on it. And then she'll fill out the amount of the check. She'll take it up to the counter and they'll deposit it. And the teller is going to look at the account number on the deposit slip, type in the amount, and done. But what if she doesn't have a deposit slip? What's she going to do? You may not know the way banking used to be. How many of you don't even use a bank? There's probably a bunch of you here. I don't go to the bank. What do you need a bank for? If she didn't have her checkbook with her, but she has her, I forgot my checkbook. Is she going to go home and get it? No. She can go to the bank, and the bank, they have counter deposit slips. Deposit slips that are sitting on the counter. They're exactly the same as the ones in her checkbook, except for what? They don't have her number on it. And so she'll take that out. She'll fill out all the information about her check. She might even write her name on it in the place where it says to put your name. But is she going to put her account number? No, because she has no idea what her account number is. And so she'll go up to the teller. She'll give the teller, and he or she will look at it. They'll say, hello, Edna, good to see you again. And they will look up the account number, probably even write the account number on the deposit slip, and then do the deposit. But if Edna writes her account number in there, there's no validation of it. So Edna will the teller will get it, key in the account number, deposit the check, give her a receipt, and done. Frank Abagnale Jr. realized this. He was kind of a hole in their process. He walked into the bank. He picked up a whole stack of these counter slips. He took them back to his apartment. He rolled them into a typewriter one by one and typed his account number onto the slips. He took the whole stack back, put them back on the counter in the bank. So now when Edna comes in, she picks up the thing. She doesn't notice there's an account number already written in it. She does it the same way she's always done it. She fills out the information, and the teller gets it, deposits the money into Frank's account. After about a week, he comes in, collects, withdraws the money. He might even just write a check against it. He probably doesn't even come in. So I wouldn't go back in the bank if it was me. Write a check and then close the account, and then gone. That was his first one. His real contribution, though, to the area of financial instrument fraud. Oh, banking is so different now than it used to be. I just got to tell you this because it's fun. He was the first one that figured out that if you printed a check with a routing number down in the, you got all these numbers at the bottom of a check. If the routing number, part of that routing number tells it what part of the country to go to. How's a check clear? This piece of paper that you took to this bank will find its way back to the original branch where the account is. And that's where they'll go, yep, you got the money in here and it'll clear. And if it doesn't clear, we write on it non-sufficient funds and we send that piece of paper back to the bank that actually cashed it, or deposited it. And when that comes back non-sufficient funds, that's how we know the check bounced. It takes a week, maybe 10 days for that to happen. And so how many of you have ever done it where you deposited kind of a large check and they said, there's gonna be a hole in these funds? Just raise your hands. Is there anyone? Maybe you've never had large checks. So today it's still kind of that, until this thing clears, you don't have access to these funds. Well, that's the only way that we know that the check cleared is if it doesn't come back. And so he figures out, I'll print a check that has a routing number that sends this thing to the other side of the country. And instead of taking 10 days to clear, it might take 3 or 4 weeks for it to clear. And after that 10 days is gone, the bank is going to release the funds because the bank just figures must have cleared because we didn't hear back. And so he could come into a new town and open an account, deposit all the kinds of checks that are clearing because they're not bouncing. And then the banks release the funds, he collects the money and walks away. Really kind of smart guy. And I think I mentioned he's a colleague. In his book, Catch Me If You Can, it doesn't make the movie, but in the book, He claims to have actually, gotten a job as a professor in the psychology department at Brigham Young University. And taught for a year or so here. Would have been amazing to have him as a professor. The university instantly denies that that ever happened, but I'm not sure who to believe in this case. Okay, so the check digit that we are going to calculate is the International Standard Book Number. So if you have a book, on the back is probably now a 13-digit number, but we kind of went from the 10-digit version, which was the original specification, to a 13-digit number like in 2007. So there was older books have a 10-digit one. There's a time where you had both a 10-digit and a 13-digit, and now if you buy a new book, it's just got a 13-digit ISBN on it. So today we are going to see how to calculate the check digit to implement this algorithm that looks so frightening up here on the board. We're going to implement this in VBA, and then you will have a project on this where you implement the 13-digit algorithm. So the stuff we're doing today is going to be really relevant to what you're doing. It's a different algorithm, but the same procedure that we're going to do. And that is, we're going to write code that will accept in a number, someone saying this is the ISBN, and we are going to tell immediately, is it well-formed or not well-formed? Now, we won't know if it's valid unless we do a database lookup somehow to find out, does this actually map to a real book? Has it been assigned? But we will at least be able to tell if it's a well-formed number. Is it valid? So that is where we're headed. Now, everything we've written so far in VBA has been in what structure? It starts with a keyword, ends with a keyword, and we have in the middle all of our macro or all of our code that we're going to do. What is that called? It's a sub. I mean, the keyword is sub and sub, so it's actually called a sub procedure. This is procedure. There's different kinds of procedures. This is a sub procedure. And so we're not going to do this with a sub procedure. We're learning a new kind of thing. So Alt F11. Alt F11, come to me, there we go. Must hit Alt F10 if that came up. All right, so I'm going to insert a module, regular old module. Now, normally we would start off by saying sub, and maybe we'll call it is valid ISBN, is valid ISBN 10, 10-digit ISBN. And I'll capitalize the V, but we're not making a sub procedure. Instead, we are making a function procedure. Function procedure is exactly like a sub procedure. Exactly like a sub procedure, except that when a function procedure is done executing, it sends a value back to where it was called from. Now, we saw this last time we were together. We talked about these built-in functions, like now. So now goes and does something. It reads the time off the system clock, and it returns that value to where it was called from, which is why it gets printed. I said print now, and it said, oh, I got to go figure out what now evaluates to. The value comes back to where it was called from. And so this is, kind of what happens here is that now gets calculated and goes, what is it? Its value comes back, and then it's just as if that function is replaced by the value that it returned. And so that will then we'll print that. So you can think of this being the value that came back from the function, and that value replaces the name of the function in wherever it was called from. Incidentally, we can do this exactly the same thing inside of a worksheet. So I could say equals now, and that value comes back here into the worksheet. So that's pretty good. Because when the function gets called, its return value gets substituted for the call itself. Does this make sense? Yeah, so and we did this a lot last week, or last time we were together, with the built-in functions. The only difference is now we are going to be making the function ourselves. So the real official name for what we're making here is called in VBA, it's called a function procedure. Out there on the so-called internet, you will often see these referred to as UDFs, user-defined functions. That's not a bad name for it, but it's not the one that Microsoft typically calls it. All right, now, because this function is going to return a value, it's going to return a value of a particular type. Just like we have types for variable, string, integer, date, currency, double precision, floating point number. functions also, because they're returning a value, they're returning a value of a particular type. Now, let's suppose that I was going to have a variable here that was a Boolean variable, dim x as Boolean. So here, dim x is all it takes to actually declare the variable. The as Boolean just gives it the type, right? I can actually leave this part off. Just dim x, that's enough. That's valid. The VBA interpreter will infer, it will guess at a type, and the type it will guess is the type called variant, which I'm not a fan of, but that's what it would do. That's why we always will put the type down here. But this part is the part that specifies the type of the variable. Well, what I'm going to do is I'm going to do the same thing to specify the type of the function. So I'm going to put just as a data type right after the declaration of a function. When I declare a variable, I say as data type to specify the data type. When I declare a function, I say as data type to declare the type of the function. So now this function can only return what? Yeah, true or false. Boolean type is just true or false. So no matter what else happens, this thing can only ever return true or false. And it's already set up to return one of those things. Every data type has a default value. All numeric variable the data types, the default is 0. String data types, the default is empty string. Date data types, the default is midnight, December 30th, 1899. Everything has to have that seems like a strange default, but that's just what 0 is in date language. So what do you think the default for Boolean is? Yeah, it's false, because false is 0. And false is the value that maps to 0. 1 or any other number is true, and then 0 is false. So if I don't ever tell this to return anything else, it's going to return false. It will return the default value, the default value for the data type. So I'm going to come over here and change equals now. You might be surprised to find out that I can now type this in right here. Is valid. Wow, it even knows it's there. It's giving me the choice. Excellent. How do I choose that? Tab? Yeah, tab. Opening and closing parentheses, and now that's bringing back false. It's bringing back false because I haven't ever told it to bring anything else back. And it has to return true or false. False is the default for Boolean. Questions? Now, our job is going to be to make this do something. I mean, right now, the algorithm is really simple. It's just nothing. Just return false every time. So in fact, we don't even know what ISBN we're working on. So if I wanted this function to be able to take a value in and then look at it, how would I tell it to take a value in? Go ahead. Right, that's exactly what these parentheses are for. And that is to be able to say, here's where I'm going to declare a variable that will get assigned its value when the user calls the function, or the code calls the function, or the formula in a cell calls the function. And so let's just call this the candidate. Now, we're going to be taking in an ISBN. As it turns out, ISBNs, these will be 10-digit ISBNs. They're most often like this, like 3 characters and then a dash. And then like 5 characters and then a dash. And then what else we have? 1, 2, 3, plus 5, that's 8. And then maybe 2 more characters. I mean, like 10 characters. So and if this is what I want to pass in to be evaluated as a valid ISBN, what do I need to, what data type should this be? Yeah, it can't be numeric because I've got all these other characters that could be in here. Hyphens, sometimes dots are really common, spaces are really common. In fact, I want to be able to accept anything that's non-numeric in there. I don't care. If it's non-numeric, just ignore it and let's just get down to the numbers. So candidate as a string. S-T-R-I-N-G. Okay, so now at this point, we're ready to send in a value to be a potential ISBN. An ISBN that someone is claiming is an ISBN, and all we want to do is return true if it's well-formed, false if it's not well-formed. So it's time for us to go look at the algorithm. So let's go back to, this is just the Wikipedia entry for ISBN. And here it will describe both the 13-digit and the 10-digit ISBN. We're looking at the 10-digit ISBN. So here is the ISBN that they're using in this example. Starts with a 0, has these other values in here, and et cetera. So here's the algorithm. We take the first character, and we'll look at it up here. We take the first character, and we multiply that by 10. So that 0 comes right here, 0. We take and multiply it by 10. We add that to the next character, 3. multiplied by 9. The next character multiplied by 8, next by 7, next by 6, and so forth. We do all those little individual multiplications. We add those up. It's like a sum product. And that gives us the first step in the algorithm, which in this case kind of evaluates to right here. We get this 130. That's what that would be. And then we've got some other math happening here. But I've drawn this out where it might be a little bit easier to read right here in this worksheet that we downloaded. So here, I've got this is a valid ISBN. I've got this ISBN here. And I take the first digit, multiply it by 10, a second digit, multiply it by 9, and so forth, all the way down to the second digit. We take the sum of that, and then we take that number, mod 11. What is mod? What function is mod? Yeah, it's like the remainder. This is going all the way back to now like 4th grade. So in 4th grade, you learned long division, and like you have do you have a dividend, do you have a divisor, you have a quotient, you have a remainder. These are the words you had to learn in the 4th grade for doing long division. And your teacher, you asked your teacher, when am I going to have to do this? And the answer is today. Today was the day you were getting prepared for in 4th grade. Because modulus is just the operation that gives you the remainder. So if I take 500 and I divide it by 5, the quotient is 100, the remainder is 0. 501 divided by 5, quotient is still 500, remainder is 1. And so I can go directly to the remainder with the modulus function. If I say 501 mod 5, that's going to give me 1. That's just an operation that jumps straight to the remainder. Question? Yeah, so in this algorithm, is it always mod 11? The answer is yes. Okay, so we add these up. We do the sum product here. We add those up. We take that mod 11. That equals some number here. We then take 11 minus that number. That goes here. Oops, I didn't make this quite right. That 6 should come right over to here. So we didn't take that 6 mod 11 again. That gives us 6 again. And then we come down here and we say, if that last, oh, by the way, if I take any number mod 11, what are the possible values I could get out of that function? Can I get 0 out of mod 11? Yeah, like 121 mod 11 is 0 because 121 is a multiple of 11. Can I get a 1 out of it? Yeah. What's the possible? How many different values can I possibly get back from mod 11? 0 through 10. Is 11 possible? No, because if I get 11 back, then there's some problem because you could take one more. I got a whole other 11 that I could use in the quotient. And so, yeah, those are my values. Now remember, what a good check digit allows us to do is it allows us to say, if any one character is wrong, I'll know it. If any 2 sequential numbers are transposed, I'll know it. And it produces a single character as the check digit. So I want to type one more thing. This one is so close, but the check digit could be anywhere between 0 and 10. In numerology, how do I say the quantity 10 with a single digit? There's a way you do it. You learned this in 2nd grade, by the way. What is it? X. Why X? Say it. Someone say it louder. Roman numeral 10 is X. And that's exactly what they did. They said if the check digit right here, right? If it's 10, then this is going to be an X. Any of you ever work in a place like a bookstore where you have to type in ISBN numbers? Anyone? Never? They have special keyboards for that. They get a 10 key pad that has an X on it, so that you can type with your right hand, you can type the whole ISBN. Now, nice thing about a 13-digit ISBN, the check digit's a little more sophisticated. The algorithm is more sophisticated, and the possible check digits are 0 through 9. So you don't have to worry about the X on a 13-digit ISBN. And when did we make the ISBN number? When did they come around? I think it was in the 1970s as well. It's the best we could do in the 1970s. We had big hair and afros and bell-bottom pants and check digits that had X in them. So that was the 70s. So now this is the algorithm that we want to implement. We ready to do it? Let's go ahead and do it. All right, so let's just say that I'm ready to run this. If I was just running a sub procedure, how would I run it here? I'll click the play button or I press F5. Let's go ahead and give it a shot. And the editor tells us here, it sounds like you want to run something. You can't run this one. Why not? It's not because it's a function. We can run functions, generally we can run functions same way we run subprocedures. Say it. Yeah, it's because to be able to just run this, I'm not allowed to be requesting a value. For this to run, I've got to give it a value. So I can't just say run because I haven't specified the value. And so I've got a couple of ways I can do that. One is I can just come up here and call the function. Well, I could do it over here. This was a bad way to do it. I could come in here and just like refresh it from here. So if I refresh this page, what is it, F9? What refreshes F9? I just deleted something, unfortunately. Let's put that back. And now this says name. Why does it say name? It's expecting a value here. I'm not giving it. So I'm going to go ahead and give it a value. I'm going to go ahead and pull the one from the example here from, where is it? Because I've got the intermediate steps for this. So I can drop this value right in here. And now that tells me that's not valid. Well, it's because my algorithm isn't really doing any calculations yet. So this would be one way that I could send a value in. I can just come back here and refresh my page every time. That's kind of a hassle to come back and forth. Kind of an easier way is to just call it from right up here. So here's the number that I want to put in. I'm going to call this function, put parentheses around the argument list, and now say question mark. And so I can just print the result of this function the same way that I print now, or mid, or in string. All those functions, I just print the results of them. I can print the results of this function as well. Why does it return false? Because I haven't told it to do anything else, and that's the default for the type of the function. It's a Boolean, that's the default value. But now I am passing this value in, and so this comes in right through this little door here. This little variable gets assigned to the value here. Even though there's no line that I say candidate equals, that's just what happens when I declare a variable inside these parentheses. By the way, a variable inside these parentheses has a special name. What's it called? It's a parameter. Yeah, let's go to the parameter. But it is a variable. It really is a named location in memory that holds a value that I can recall just like any other variable. Okay, that looks pretty good. Let's do one more thing that will be helpful for your development in this, and that is I can just create a sub-procedure. My Acme, did I talk about this already once? I think I must have. It sounds familiar. My Acme function runner is a sub-procedure that takes no parameters. And that's nice because this one I can just run. And so here now I can just say, no, I want to print the results of this function. So this one I can run because it doesn't have any parameters. So usually this is what I will do is I'll set up some sub-procedure that I can run with whatever test value I'm working on, whether it's a sub-procedure or a function procedure that takes the parameters. This way I can run it. I always start it with an A just so it will be alphabetically small. So that when I'm down here and press F5 by mistake, the default one will be the alphabetically first procedure that I can run. And that way I don't have to click on it. I'm just ready to go, oh yeah, I forgot. And then I'll hit enter to run it. Okay, so this is here only for debugging as we go. Questions? We ready to move on? Okay, so what are we going to do? We've got to be able to accept ISBNs in this fashion that are kind of poorly, and by the way, what characters go in between here is not standard, and where the characters go is not standard. So we can't say, oh, the 2nd, 5th, and 12th, well, there's no 12th, and 8th characters are, get rid of those because the order is not standard. The order of the non-numeric characters isn't standard. So there's a pretty good idea. We learned the replace function. Replace any hyphens with a zero-length string. Trouble is, could be hyphens, could be periods, could be spaces. Those are the common ones. And the truth is, if it's not a number or X, I don't really care what it is. I want to get rid of anything. I don't care where it is. I don't care what it is. If it's not part of the valid numbers for me calculating this, let me just get rid of them. So there's no built-in function for that. We're going to have to do that ourselves. So let's go ahead and do that. In fact, maybe we'll take a little detour here from isValidISBN just to make a function called valid digits. Valid underscore digits. Again, here we'll take in some data as a string. And data, just a variable name, could have named it anything. This is going to return what type? We're only sending back the characters that could be in an ISBN. So what type? Should it be long? Let's see, is long going to work? Long is plus or minus 2 billion. No, that doesn't work because a billion is a number with 9 zeros. And so if I had a 3 with 9 zeros, that could be a valid ISBN, and that's not big enough for a long integer. So double would be big enough, but double doesn't work either. Why not? It does accept decimals. That's okay. It doesn't have to have a decimal. What is it about a 10-digit ISBN that won't work for any numeric type? The X. Yeah, it could be an X. And so no good there. So, it's going to return what? As string. All right, so actually maybe I'll comment in my function runner up here. Maybe I'll comment out this one. Let's first build our valid digits. Here. Okay, so here's what I'm going to do. I'm going to bring in, I want to look at these, what gets passed in. I want to look at these characters one at a time. Do you see how this value is going to come into this function and be called data? It'll be sitting in a variable that has the name data, a location in memory that has the name data that I can then refer to. So I'm going to want to look at this one and ask the question, is that valid? What makes it valid? How can I know if it's valid? Yeah, it's numeric, or it's an X. So, so let's do this. I'm gonna have to look at these one at a time. That's gonna sounds like it's a great setup for a loop. So let me declare a couple of variables here. I'm gonna use a for next loop. So I'll just declare X as an integer. Actually, I'll be fine here, I think with, let's use integer. And someone could give me a long, byte would be my other choice here. And for that to be not big enough, someone would have to give me an ISBN that's longer than 255 characters. I have a hard time thinking someone's going to pass me a suspected 10-digit ISBN and have it be 256 characters or more long. So I could probably get by with byte, but for an extra byte, I can get it to 32,000. I like that better. So dim x as integer, for x equals 1 to the length of whatever's passed in. Next. Let me just debug dot print x. So this should print. So what do I expect this to print out? Now, because we're printing the results of this, and this is a string, it's going to print until we tell it to send something else back. It's going to print a zero-length string. We won't see it printing that because zero-length strings are really hard to see. Nigh impossible, one might say. But we do have this print statement. What's it going to print? When I run this code here, what will it print? It's going to print something up here to my immediate window. What's it going to be? Someone just tell me one of the numbers it's going to print. 1, then 2, then 3. Yeah, it'll print a 1 for this digit, 2 because it's gonna move x from the range 1 to 13 because that's how many characters I'm passing in. And so it should print 1, 2, 3, 4, 5 all the way to 13. Let's just see if that's the case. I'll run this, and there they are, 1 through 13. Now, I don't want to print x. I want to print the digit. I want to print the 0, and then the hyphen, and then the 3, and then the 0. Maybe I'll do them both. I'll print x, I'll put a comma, then I'll print the character. Oh. We saw everything we need to do to be able to do this part in our last class. So of all the functions we talked about on Monday, what might help us here? Let's take a look at mid. Mid, well, let's look at data, which is the string that's getting passed in. Start looking where? Yeah, look at the xth position. So the first time through, I'm looking at the first position, second time through the second position, and return how many characters? Just one. Yeah, excellent. So now when I run this, I should have deleted off my last run first. I get x is 1. When x is 1, I'm getting the 0. When x is 2, I'm getting the hyphen. 0 hyphen 3, 0 hyphen 3, 0 6 hyphen, 0 6 hyphen. I've got them all. Should end with a 2 down here on 13. Ends with a 2. Excellent. So now I just have to look at that value and then decide if it's a keeper or not. And so I think I'm going to have a variable for that as well. I'm going to call it one character or one char, C-H-A-R, as a string. So instead of printing this off, I'm just going to set one char equal to that. Now I'm going to check to see if it's a valid character. If, here's another, we didn't spend much time on this one, but I introduced this one to you on Monday as well. Something that can look at a string and tell me if it's numeric. What's that called? Is numeric. If is numeric, looking at one char, or what? That'll give me 0 through 9. What? Or if it's an x, or one char is equal to x. Then, and we'll have the end if down here. What do we want to do if that's the case? Well, that's a keeper. That is one we need to keep. So here's what I'm going to do. I'm going to declare yet another variable up here. I'm going to call it temp as a string. Strings have a default value too. What is it? Yeah, empty string, 0 length string. And so inside my if statement, I'm going to say temp is going to take on a new value. It's going to be its old value, temp, concatenated with my one character. So the first time I go through this, temp is going to be, temp is a 0 length string. One char is going to be 0. And so I'm going to say my new value for temp is 0 length string concatenated with 0, which is just 0. The second time that I come through the loop, come back to my code, the second time I come through the loop, I'm going to have a hyphen. Is hyphen numeric? This is my second value for one char. Is hyphen numeric? No. So this part will be false. But the whole thing could be true if only this is true. Is hyphen equal to x? No. So these are both false. The whole thing is false. I skip right by this. Third value that's going to be in one char is 3. Is 3 numeric? Yeah. Is it equal to x? No. So I have false. I'm sorry, I have true and I have false. So the whole thing is true. So we come in here and now temp is going to equal its current value, which at this point is 0 from the prior runs. And I will concatenate on the 3. So now coming out of this, temp will be 0, 3. And the next one will be another 0, and that will come through that same gate and get concatenated onto the end. So this little trick here lets me kind of accumulate values into a string. Just tack another value onto it, tack another value onto it. So I think we're really pretty close. All we have to do now is return that value. Now, in most languages, in most other languages that I know, the way you return a value is with a keyword return. I'm going to return this value. That's not how we do it in VBA. In VBA, we set the name of the function equal to what we want to return. And so that's how we establish the return value for the function. So now if I run my function here, my Acme function runner, it's going to give me just back those valid values. If I have x on the end of this, it should send back the x. If I have an x anywhere in it, by the way, it should send it back. So we'll have to deal with that as well. But this will at least get me down only to my valid digits. Did I take your question already? No. Oh, go ahead.
So does it not take into account that data comes in as a string and then when we pull it out as one char and this function, it just pulls out the number? So
no longer is a string, or how does VBA kind of decipher a string?
So here's the question. Well, the question is, this thing's coming as a string. And yet, when we're taking off just one of these things and we're putting into one char, which is also, by the way, a string. And now we're asking it if it's numeric. But it's a string, how could it possibly be numeric? And the answer is the isNumeric function actually takes as an input a string. It's expecting a string. And then it says, could I convert this string into a number? But if it wasn't expecting a string, and this is part of the philosophy of VBA, it's going to try to help you out here. A lot of languages would say, sorry, it's the wrong type, I'm not going to do it. But VBA says, well, I'm expecting a string here, but you gave me, I can convert almost anything into a string. It'll do the conversion for you automatically. So even if it was expecting a number, it would convert it to a string for you. In fact, we'll be relying on that to simplify our code in the example that we're writing today. We'll have individual characters that are strings, and we're just going to ask they equal numbers, or we're going to multiply them together. And VBA is going to go, you want to take 10 and multiply it by a string? That doesn't make any sense. Now, there's some languages. Python. What happens? You don't know Python? If you multiply a string times 10, what will Python do? It'll return a string that's the string you had just 10 times. Take the string multiplied by 10, it gives you back a string. VBA goes, no, we'll multiply it. We'll do math if we can convert it into a number. We'll try to convert it, and if so, we'll convert it and then do the math. So we're just kind of different environments that treat those ambiguities differently. Go ahead. Oh, are there any non-numbers that could inadvertently be coerced into being a number? And the answer is in VBA, no. Like 5.5 as a string will go to the number 5.5, but that's a number. The point by itself will not. Okay. Okay, so I think we were getting back our valid digits. Now, the only thing that I'm a little bit worried about is that what if someone passes us a capital X? That might be a problem because we're looking for lowercase x. So we could write that into here, but I'm going to treat that. I think I'll just remember that's an issue I'll have to deal with. Okay, so now I think the first thing I'm going to do, I'm going to declare a variable in here, dim, I'll call it ISBN, as a string, and I'm going to make ISBN equal, and I'm going to call my valid digits function, and I'm going to pass it the candidate. So whatever gets passed into this function, we're just going to pass the candidate on through. So now I'm going to get my ISBN will only be my valid digits of my candidate. But because I want to anticipate this capital X coming in, I'm just going to LCase the candidate before I send it down. So now I've got my candidate that's passed in. I'm passing that to the built-in function LCase. Its value will get returned. The lowercase value of the string will come back here. I'm going to pass its result to my user-defined function, valid digits, and the value of that will come back and go into the ISBN. And this is a really common thing that you'll see. A function gets called and sends its result right back into another function, which sends its result right back into another function. We get these kind of function calls nested pretty deeply. But you're already comfortable with that. Why? You do that in Excel all the time, right? You're writing this long formula and you're calling functions that are returning their values right into. So it's the same thing here. All right, so at this point, I should be able to look at ISBN and I could say, I'm not sure if it's right, but this one that I'm looking at, I can't be sure at this point, is it right or wrong? But in some situations, I could look at this and say very easily, that is totally wrong. There's no way that's a valid 10-digit ISBN. A really simple comparison that I can make right here. What is it? Yeah. At this point, I should have 10, not quite yet, because I could have a bunch of X's. I've got X's coming back, like all these X's would be coming back. So let's do one more thing here. In fact, we'll just wrap this in one more function call. Are we having too many functions? It's kind of like Inception. Do we have too many function calls here? Or can we handle one more? I'm going to just take this whole thing, which is what comes back from my valid digits, and I'm going to send it to the replace function. replace. Replace function takes some string to operate on, and then it looks for something. I'm just going to put some placeholder in there for now, and it's going to replace it with something. So I want to look for lowercase x. Oh, I'm not quite here yet. Let's do, I do want to do this as a separate step. So let me back this off. Okay, I'm going to declare another variable here. Before I do this, I want to split off my check digit. So let me dim my check digit as a string. And after I've got back my valid digits, I'm going to make my check digit equal to what? Tell me the VBA that I want to use here. Yeah, just write the last digit of my ISBN. So check digit equals the right of ISBN, comma 1. It's going to be the rightmost character. Now, this is great because if it's an X or a digit, it'll be there. But what if they put in something like, a hyphen after it? That's okay, because that hyphen is going to evaporate as it comes back from my valid digits. So at this point, my check digit will either be an X or it will be a number. So that's great. Now, for my ISBN, I don't want any X's involved. And so, I no longer need that last character as part of my ISBN. I'm separating this because the way I calculate the algorithm is I take the last character, take it and set it aside because that's what I'm trying to calculate, and then I'm going to take the rest of the string and I'll work on that. So I'm going to take ISBN and set it equal to everything but the last character. How do I say that? What function? Don't have to know the whole thing. What function might be good for this? Left will be good. So I'll take the left of ISBN. How many characters? However long it is, -1. I got 13 characters, I want the left 12. If I got 10 characters, I want the left 9. Okay, and now maybe I'll do this in a separate line as well. So now is where I might have those extraneous X's now still sitting in my ISBN. Am I allowed to have any X's in the non-check digit portion of the number? No, those all have to be numeric. And so here's where I'm happy to kind of get rid of those, any extraneous X's that might be there. ISBN is going to equal my replace function, looking at ISBN, looking for something, replacing it with something. I'm looking for lowercase x. I want to replace it with empty string. Yeah, that will just get rid of it. Okay, so now at this point, I've separated my problem into two halves. The check digit that I'm trying to calculate, I'm trying to see if when I apply the algorithm, does it actually produce that check digit? And the other half, which is the numbers that I'm trying to put the algorithm on. So now I can look at ISBN right now, and there are some situations where I could say, there's no way this is right. What might be a situation I could look at that and say, there's no way this is right? That's right. At this point, that should be exactly 9. If this is a valid 10-digit ISBN, my check digit is 1. I got to have 9 other characters. If I have 10, it's not valid. If I have 8, it's not valid. And so I'm going to come right here. And even though, I'm not going to try to look for every possibility, but this is just so simple. I'm just going to do it. I'm going to say if the length of ISBN is different from 9, then exit function. At this point, at no place in my code before this line have I ever said that is valid ISBN 10 equals true. So what will it return? It will return false. So at this point, I've said, well, this can't possibly be valid. Get me out of here. Yeah. Oh, the question is, is there other ways to say not equal to? And the answer is yes. I could put an equal sign here, and I could put not in front here. But in a lot of other languages, you can say not equal to this way, and that's not VBA. Yeah, not equal in VBA is this way. But since I have the word not out there, I'll put this as equal. Not equal to 9 is another way I could say it. Okay, now the great thing is, if I made it here, now I know that I have 9 numeric characters in ISBN. And knowing that is going to be really helpful to me. Because if I try to, what happens if I try to take the mid of a 4-digit string and I tell it to take the 5th character? That's an error. And so now, if I made it this far, now I know I've got 9 characters. I don't have to worry about being out of bounds. Because if I'm here, I know I have the 9 characters to work with. That's going to be great. Oh, and we have 9 minutes. That's good. 1 per character. We should be able to do it. So I'm ready to start doing this calculation. I'm going to need some way to kind of keep track of my interim steps over here. So I'm going to declare, I'm not sure, and these names, I'm not sure I've given very much thought to what I should call these. I'm going to call this one the checksum. And I'm just going to use this for kind of intermediate steps as I'm going along in my calculation. I'll make this as an integer. So now let me just kind of do that first part. I'm going to say checksum is going to equal to what it used to be. And I'm doing a little bit, I'm kind of bypassing a step that I would like to help you see because we're kind of short on time. It's going to be equal to what it used to be. By the way, first time I hit this statement, what did checksum used to be? With the initial value of checksum is 0, because it's a numeric data type, numeric variable, numeric data type, plus the mid of my ISBN, starting at 1 and taking 1 character, right? That's the first thing here. I'm getting this 0 right here. And now I am going to multiply that by 10. So let's see, the order of operations is going to take this multiplication here and happen first. Now, as it turns out, mid is a string function. It takes a string to operate on, and it sends back a string. And I'm taking a string and multiplying it by 10. But because in VBA, I know that if this string can be converted to a number, VBA is going to do that automatically. I'm just going to let that conversion happen without doing it expressly. Let's look at my second one here. The second one is going to be looking at my second character and multiplying that by 9. Third one is going to be looking at my third character and multiplying it by 8. Do we see any patterns here? The truth is, there's only 9 digits here. I'm a third of the way there. Maybe I should just keep going. But I want to show this to you as a loop. So let's go ahead and declare a control variable for another for loop. Dim x as an integer. Actually, byte will be just fine. Let's do byte for this one. And now I'll make the loop here. For x equals 1 to 10. Next. And let me just see if I can make an expression that will print out. These lines are exactly the same except for what's in this position and what's in this position. And if I can make a loop that will print out that series, 1, 10, 2, 9, 3, 8, then I'll be ready to just kind of build this loop with a single statement inside. So how will I do that? Debug.print. I'm going to print x. That's going to give me the 1, 2, 3. And then how do I get the 10, 9, 8? How do I do it? Yeah, just 11 minus x. So now when x is 1, this will print 1, this will print 10. When x is 2, this will print 2, this will print 9. You just run that and it should print off those values. Did I not say print for x equals 1 to 10? Oh, I haven't moved this over to is valid ISBN. So let's change this and run that again. That needs to say string. And now I've printed off that. Oh, no, that is the mid starting at 1. Still not sure. I'm printing x, which should be 1, and that should be my other number. Let me run that and see what I got. There we go. 1, 10, 9. No. Oh, yeah, that is 1, 2, 3, 4, and then 10, 9, 8, 7. So that's the vector that I'm going after right here. So now I'm just going to bring one of these lines up into my loop, get rid of the others, and where I've got that 1 is going to be x, and where I've got the 10, it'll just be 11 minus x. And I'm putting this in parentheses because I want this subtraction to happen before the multiplication. So now, after this loop runs, I don't need to be printing this off anymore. I should be able to print my checksum. Let's run this. Checksum equals checksum. Mid of ISBN starting at x, multiplying by 11 minus x. X is 10 minus 1. Oh, this is not 1 to 10. What is this? This is 1 to 9. Remember how I said if I went out of bounds, it would cause an error? Yeah, I'm trying to look at the 10th character of a 9-character string. So that was just an error there. Let me run this again. Okay, so now this is giving me the 130, my interim step. That's the 130 that I'm supposed to be calculating here. And the false is coming because I'm printing the result of is valid ISBN. I haven't told it to return anything but false, so it's still printing false. How are we doing? By the way, where I expect you to be with this example at this point in the class is to say, Professor Allen, I am pretty much following what you're doing. There's no way I could have done this by myself. Yeah, that's where I expect you to be. Here, right? This is we're plowing new ground here. You know, you're understanding all the parts of what I'm doing. You couldn't have put them together yet yourself. We'll give you some experience for that. All right, let's just look at the next step. So what's my next thing? So here's my 130. It looks like my next thing is to take that mod 11. I don't need the 130 hanging around for anything else, so I'm just going to use the same variable. So after I come out of the loop, I'm just going to say checksum is equal to, what was it? That number mod 11. So checksum, I think I'm going to copy that because I'm going to have to type that a bunch in the next little bit. Mod, that's how you do mod in VBA. It's just the word mod. It's an operator like plus or multiplication, mod 11. Then what's next? Then it's 11 minus that number. So checksum equals 11 minus checksum. And then it's that number, mod 11 again. I got a whole line for that one. And then we're done. So at this point, I'm ready to look at what I've calculated and check to see if it equals my check digit. We still have x to deal with. Let's deal with x first. So let's do this. Let's say if my checksum is 10. Then we'll do something. What are we going to do? Now, let's check to see if if the checksum is 10 and my check digit is equal to x, the checksum is 10 and the check digit is x, what does that mean? Yeah, that's valid. So name of my function is valid ISBN equals 10. Let's see. There's a problem here. I'm going to do this in 2 steps. If it's 10, then let's bring this in as another if statement inside. I'll explain why in a minute if we have the chance. Then I'm going to say if my check digit is X, then, and if. The problem is that if I have a check digit of X and I calculate 9 from here, then I still have a possibility of having this non-numeric check digit, which is going to be a problem in my next step, which is right here. Else if my check digit is equal to my checksum. So 10 is a special case. Otherwise, if what I calculated is equal to the digit that I pulled off, oh, is valid ISBN equals true. You're wondering, what's the 10 there for? Then it's true. And if. Now, I've got 2 conditions that are going to switch me into true. Go ahead. And if, that's okay. This and if goes with this if. And then this if goes with this else if and this and if. That should be it. Let's check it and see if it works. Is this still my valid one? This should be true. Yeah, just a minute. Yeah, so that's true. Let me change this to something else like X and run it. I think I need to reverse these. If I've got an X in here, then the only possible thing here is this. That's the way we need to write this. Otherwise, we end up trying to compare a number to X, and it confuses VBA. So now that's false, and that should be a good solution. Does this show you what you want to see? Whew, a little bit rushed there at the end. I spent too long talking about Frank Abagnale Jr., but the truth is he's more interesting than writing functions to calculate check digits. All right, so if you felt like you got a little lost on the end of this, I'll have this recording posted that you can kind of go back and look at it again. All right, thanks for coming. Class dismissed.